Okay, teachers, welcome to Educator's Edge, Enhancing Instruction. Today we are covering TEK 4.7a, where we are looking at descriptive investigations of forces of magnets. And those of you that are watching this asynchronously, if you don't already have these materials on hand to use during this session, please pause right now and make sure you get these things and have them available before you continue. Okay, well, I am Kristen Conrad. I am the science specialist. Your other presenters today we have Amy Snyder, she's our science IST, and we have Jenna Hudon, another science IST. They're over there together. They're going to be leading us in some fun learning this afternoon, or a little bit later in the session. Today's learning outcomes are understanding the targeted TEK, analyzing assessment questions, we're going to experience a lab, and we're going to review some instructional resources that you have available to support you in teaching this TEK. So here are the norms for this virtual session. If you can please keep your camera on. It's much better to be able to interact and see what you're doing, especially if you're going to be participating with us. We'd love to see your setup and what you're doing. Please use the chat. We're going to ask you some questions and ask that you participate. So please have your chat ready and answer our questions in the chat if you would, and honor the session time by staying until the end, and make sure you fill out the feedback form to receive credit. If you have any questions as we're going through the session, if you'll please drop them in the chat, and we will be sure to get to those at the end. We have some time set aside specifically for your questions, but we don't want you to forget them, so drop them in the chat. All right, so we're going to get started today with looking at some historical data, starting with the STAR. So this standard, which the new TEK is 5.7b, but when you're looking at historical data from 2024, back then it was 5.6d. Both of them are the same content. And so in 2024, Northside had 19% of our students show mastery on this standard, and we did improve last year in 2025 with 40%, but it still landed this TEK as a hotspot TEK. So as a district, we are trying to really do everything we can to support teachers and improving instruction around the standard, and hoping that it'll bring up our scores for STAR. So fourth grade teachers, if you're a fourth grade teacher here, thank you, because your role in the fifth grade STAR, actually it's not fifth grade STAR anymore, it is now the elementary science STAR, grades 3 through 5. So just know that your content is extremely important to the success of our students on the science STAR when they take it in fifth grade. And looking at last year's unit assessment data, this standard had 75% of our students showed mastery. And just a note on that, this is a very unique TEK in fourth grade, in that we separated it into 3 separate units. And so when we look at the data that I'm sharing regarding the standard, it's actually taking the data from all 3 unit assessments and putting them together just to represent our achievement on this TEK. Last year, the force of magnetism, which is in your attractions to Texas unit, this did not have a question. This unit assessment did not have a question on this TEK. But we've added one, and we'll look at that in a minute. So this is just to give you a little bit of background, so you know why we are here today around this standard. So let's get into the TEK. Let's unpack our standard. So this is the full TEK 4.7a, plan and conduct descriptive investigations to explore the patterns of forces And you'll see that we've marked out gravity and friction because we look at those forces in the other units. So in your unit you're about to start, the attractions to Texas, you're looking at magnetism. So forces such as magnetism in contact or at a distance on an object. And I do want to make sure we note that the beginning of that TEK is students will. So students will plan and conduct descriptive investigations to explore the patterns of forces such as such as magnetism in contact or at a distance on an object. So first I want you and your teams to look at the standard and identify the verb or verbs. And as soon as you find the verbs or verbs, if you will drop those in the chat for me, please. Good. Good. All right, we've got those in the chat that are all looking about the same. And then the next part of the TEK is what is your content? So we know the verbs, what the students are going to be doing. What is the content? So if you and your team will talk about the content that's important here and drop some of it, some keywords in the chat. Good, good, good. Excellent. Okay, and we are going to, there's our answers. So everyone got it, nailed it with your verbs. So the students are going to plan and conduct. So this TEK is interesting because you've kind of got two parts to it. So the first part is they're going to plan and conduct a descriptive investigation. The second part of it is they're going to explore patterns of forces such as magnetism in contact or at a distance on an object. So when we get into the model teach, you'll notice that it's a little bit different. Instruction is a little bit different when we have plan and conduct a descriptive investigation because that is not a TEK that students can explore and discover. Students can't really discover how to plan and conduct an investigation. So you're going to see that we use a gradual release model for that portion of the TEK, but they are exploring patterns and forces. So very good. And then this is the learning target we have available for you, which is just to kind of bring clarity around it. And in this case, we really just left out gravity and friction and just put magnetism in there. The other thing I wanted to bring your attention to is that in the science TEKs, it's important that we're doing 3D learning, that we're bringing in not only the content TEKs, but we're also incorporating the science and engineering practices or the SEEPs and the recurring themes and concepts or RTCs. And some of our TEKs actually already have a SEEP, some SEEPs and RTCs embedded in the standard, and this happens to be one of them. So if you'll see, I already listed for you the SEEP and RTC that are embedded in the TEK. So I'm going to give you a minute to see if you can find where 4.1b is embedded in 4.7a and how 4.5a is also embedded into 4.7a. And if you guys will give me a thumbs up when you kind of found those. Okay, I see one thumbs up. Thank you, Edna. Oh, good. I'm seeing some thumbs up. Yay. Okay. So it looks like this. So when you have plan to conduct a descriptive investigation, that's using the science and engineering practice of planning and conducting a descriptive investigation. And when they're exploring patterns and of forces, that is the recurring theme and concept of identifying and using patterns to explain scientific phenomena. So this standard already kind of is written to include all three dimensions of science instruction. Okay, so this is the unit assessment question that we added to your unit assessment for the attractions to Texas so that we ensured this hotspot teak was assessed. So I'm going to give you a minute for you and your team to look at this assessment question and think about what, knowing this is how they're going to be assessed, what does that mean about what students need to do during the unit and what they need to know by the time they get to the unit assessment? Feel free to drop any thoughts into the chat. Okay, so to me, one thing I want to make sure to note when I'm looking at this assessment question is that my students are very clear on forces that occur at a distance or forces that occur in contact. Oh, good. Force of magnetism, explanation, the difference between attract and repel. Absolutely, because that language is on here. So perfect. So looking at your unit assessment will definitely equip you with the vocabulary that you need to be using during your instruction and that you ensure students are using to explain their learning. And this is what this TEK looks like by the time your students get to fifth grade and they see this TEK on a star, fifth grade star, sorry, elementary science star test. I'm just going to give you a minute to look at that. One thing to note with this particular STAR question is that when the students get to fifth grade, it changes from a descriptive investigation to an experimental investigation. So it's much more complicated, but I wanted you as the fourth grade teachers to see how the rigor of this TEK looks in fifth grade so that you can make sure that you're hitting the vocabulary. Because if the kids can come into fifth grade really strong with the vocabulary, that'll help the fifth grade teachers really work on the experimental design where they have to know variables and all kinds of things. So this is what it looks like in fifth grade, and they are trying to figure out how to improve the investigation, which is just to make sure they have one independent variable. Okay. And with that said, we are going to jump into the fun part, and Jenna is going to lead you in a model lesson. So I'm going to hand it over to Jenna.
Hey guys. So I know you see where I'm speaking, it says Amy. My computer decided that now would be a fabulous time to make some updates. So know that it is me, Jenna, talking to you. Okay. So for this descriptive investigation, we are focused on the forces of magnetism. This model lesson piece is going to follow the guided question, how do magnets interact with a variety of objects? You see here the science engineering practices that we have pulled out for you, and these are in your curriculum, as well as the recurring themes and concepts we've pulled out for you as well, again, in your curriculum. Now, this is just one that we thought fit well. Remember, if you or your students can justify other recurring themes and concepts, then that is totally fine. It's correct. You are on the right track. Okay, so I'm going to start sharing my document camera with you. And we will get started. Okay, can everyone see the document camera? Yay. Okay, beautiful. So I'm going to talk you through this descriptive investigation, forces of magnetism, okay? And side note, I'm using the script. So we're going to talk about this script in a moment, okay? In the you do or in the I do portion, right? I'm the teacher. I'm going to carry out the I do. And I'm thinking out loud to myself. I'm modeling this thought process to the students. All right. And I'm using my script to guide me. So I'm going to say to myself, okay, guys, today we are investigating this question. How do magnets interact with a variety of objects? So I need to think to myself, what materials do I need to be able to do this? I'm going to need some magnets, a variety of magnets. I'm going to need different materials, ones that I think might be magnetic and not be magnetic, just a variety. So I have my materials right here set up for me, so I'm good to go there. Now, how will I set them up? Right now, I just have them kind of laid out, but to carry out my investigation, maybe I'll have my items on one side, and then I'll have my magnets off to the other side. So maybe I'll start generating my surface, my testing area is going to be right here. So I have my materials, I've thought through how I'm going to set them up, and now I need to think about what data will I collect? Well, my question is, how do magnets interact with a variety of objects? So maybe on one side, I'll make a chart, and maybe on one side, I'll have the objects, and on the other side will be the interactions or what I observe. And so I think that my journal page is going to end up looking something like this. Remember, we're talking to our students here, right? We're modeling this for them. So boys and girls, I have my title, I have my question here, so I can always refer back to this, remind myself of what I'm trying to answer. And then we see here my items and my spot for my observations. So I'm going to go ahead and carry out this investigation. I have these three here that we're going to explore together, and then we will write down our observations. So, boys and girls, it says right here, I'm going to try out the paper clip and the circle magnet first. So I'm going to pull out my paper clip and my circle magnet, and I will see what happens with my paper clip and my circle magnet. What happened? It attracted, right? It pulled the paper clip to the magnet. So I'm going to write down what I observed. Paper clip was pulled towards the magnet. All right, awesome. So I see what happened there with the paper clip and the circle magnet. Next, I'm going to see what happens with our circle magnet and our wand magnet. So I'm going to grab those two items. I have my wand magnet here, my circle magnet, and I'm going to explore and see how they interact. Oh. Look, our paper clip's coming along for the ride. I can see here that my wand magnet is doing what to my circle magnet? Oh, it's pushing it. All right, so I'm going to record that in my journal. So I have circle magnet, wand magnet. My wand magnet pushed the circle magnet. All right, we're doing good. We're on the right track. So lastly, I want to test my rubber band along with a wand magnet. So I'll pull those items out. I have my rubber band. I have my wand magnet, and we shall see what happens. I'm not seeing any sort of reaction or interaction. So in my chart, I will write down no interaction. So boys and girls, I have tried some of these items out to see what is occurring. Remember, we're focusing on the descriptive investigation part, how to carry out that investigation. And so once I've carried out that piece, I'm going to start thinking to myself, some follow-up questions here. So I'm going to think to myself, okay, what forces were created by the magnets? I'm looking here at my chart, my observations, and so I'll ask myself, what forces were generated here? So I see paperclip was pulled, so I know that's a force. Long magnet was pushed. I see a force there. And then this one had no interaction. So what forces were created by magnets? A push and a pull, right? Okay. And what materials or items did the magnet push? So again, I look back at my observations. What item or material did the magnet push? Well, it just so happened that a magnet pushed another magnet, right? And so we might even want to talk about, there's a special word for that, boys and girls, right? And so a magnet pushed another magnet. Okay. And what materials or items did the magnet pull? Well, I see here that the magnet pulled on the paper clip, right? The magnet pulled on the paper clip. So to carry out my descriptive investigation, I talked to myself about the materials, how I would collect the data, how I would write this data down, and then some follow-up questions for myself to kind of solidify my understanding. And scene. That's you carrying out the I do portion, right? For your students. You are modeling it. What is happening in your brain is coming out in words for them to see. Because for a lot of our kiddos, this might be the very first time that they're able to carry out an investigation like this. And so you really want to model that for them. So I want to give you guys, I was going to say at home, I want to give you guys in your classrooms a couple of moments to explore with your magnets and the items before we transition to the we do and you do portion, okay? So if you can, let us see you doing this so we can spotlight a few of you just for the next couple of minutes. Pull up. Don't be sorry, Edna, you're doing great.
We're also doing a supply list.
We're doing, what else do we need?
Supply list.
Give you about 30 more seconds, everybody, to investigate before we move on. Okay, if you can set your investigation materials off to the side. And I'm going to share my screen with you as we carry out discussing the we do and you do portions. Okay, thumbs up if you can see the descriptive investigation script. Beautiful. All right. So the I do was very much you sharing what's in your mind, right? As you carried out that descriptive investigation. So with the gradual release, we now step into the we do. And so just like it sounds, your students are now joining you in that journey of carrying out the investigation. So you are going to ask your students, you'll tell them, boys and girls, we are going to plan and conduct a descriptive investigation together today. So you watched me the last time, and now this time I need your help carrying out this investigation, okay? So guys, let's generate a list of questions. So you'll have your students support you in generating a list of questions that they could investigate around the idea of magnetism. And so in the descriptive investigation script over here, you see me scrolling down to the we do section. We have generated a list for you of some of the questions that could possibly come up, but you definitely want to take their lead, okay? So when you're generating the list of questions that they're providing you with, you want to pick one of the questions they come up with. Now, if they're just stumped and they're not really giving you much, then we've given you this support here to kind of get you going, all right? So for the sake of this PD, we're going to say that our kiddos told us that they want to investigate this one here. Do larger magnets have more strength, okay? So boys and girls, we have decided to investigate this question. Do larger magnets have more strength? So again, we need to focus on these questions here. Now you see what I'm circling with my mouse? I would encourage you to have these printed out for your students on a piece of paper. This is going to be like their guide to carrying out a descriptive investigation, okay? So boys and girls, we need to walk through these questions, all right? So remember, our question is, how do magnets, pause. Our question is, do larger magnets, right here, do larger magnets have more strength? So in order to do that, boys and girls, number one, what materials do we need? You're my boys and girls right now, teachers. In the chat, can you tell me what materials will we need to carry out that investigation of do larger magnets have more strength? Yep, various size magnets. Different magnets, absolutely. Yeah, maybe some paper clips, maybe things that are magnetic and are not magnetic, right? Y'all got it, yes. And so my next question I see here is, how will we use these materials? So how are we going to use our variety of magnets with different sizes and those items that may or may not be magnetic? How are we going to use those? I see your wheels turning above your heads. Absolutely, Edna. We're going to explore, right? Just simply that. We're going to explore these items and these magnets and see if we can answer that question. Next, what data or data will we collect? Now remember what your guiding question is. That question was, do larger magnets have more strength? So what data will we collect? See how many paper clips a magnet can hold. Yep. Maybe weighing the objects, how close a magnet has to be. Yep. How fast it occurs, or maybe how fast it moves the item. Yeah. So you guys are telling me all about your observations, right? So we'll need to collect our observations. And so then, boys and girls, how are we going to organize that in our notebooks? Maybe a graph. Maybe a chart? Yeah. A table? Absolutely. So then we would generate together a table, right? I'm pausing my teacher talk. So then we would generate with our class a table in order to collect that data, right? Because then that last question is, will the data allow us to answer the question? And our hope is that yes, we will be collecting our observations to then be able to answer the question, which right here is, do larger magnets have more strength, right? So then you would carry out that descriptive investigation with your students supporting you. Whereas before you did all the talking and the leading and the chatting, and now you're going to bring them into that conversation of carrying out this investigation. Okay, so it's the gradual release piece of that. After you carry that out, there are some follow-up questions to share with your students. So if we are looking here at the script, you see these follow-up questions. Now, you want them to go along with the question your students have decided to answer, right? And so you may end up asking them things like, what do you notice? What do you wonder? What data aligned with what you expected? What surprised you, right? What was shocking or surprising? And did you notice any patterns occurring in either the data you collected or maybe the way you saw things reacting? So you just want to get that conversation happening because you are helping them understand how to carry out that descriptive investigation, right? So the thoughts that are coming to their minds. So once you've done all of that, you have carried out the we do portion. So it was all on you, you were leading it, then you brought them into that conversation with the we do. And now you are going to set them up for success to carry out the you do portion. And so by you do, of course, we mean our students, right? So we have these questions here on a piece of paper because that's going to be like the lifeline to carrying out this investigation. You give them those questions. You say, boys and girls, remember that list of questions we generated together? You can choose a question from there. Maybe a question has popped up into your head that you want to investigate, but pick. Your group is going to choose the question you want to investigate. You let them choose that question, right? Then you say, okay, ladies and gentlemen, you are now going to have time to answer these questions here as a group. Have them write down their answers to these questions because what they will then do before you let them move on to investigating is they're going to share that plan with you. Okay, you'll read through, see if they've answered those questions well enough to be successful. Because remember, for a lot of our kiddos, this will be just the third time they've had a chance to carry out a descriptive investigation, right? We want them to be successful. So read through their plan. Do they have everything they need to be successful? If so, awesome. They get the green light to go on and do the investigation. If not, that's when you, the teacher, step in, give them some tips and support them. Like, oh, you might need, how are you going to collect your data? Like you told me you were going to collect your observations, but how, right? And you help them in making that table or that chart, however they want to collect their data. Remember, collecting data too can also be just writing down observations. So if they want to carry it out that way, that's perfectly fine as well. You let your kiddos carry out those investigations on their own, and then they come back and you ask these follow-up questions. They're the same from the we do, okay? So you ask those follow-up questions for them to kind of synthesize what they did during that investigation. This last piece here, you see it says have groups share their questions, investigation, and conclusions with the class. This could happen in a variety of ways, right? It could be them standing up and talking about it. They can generate some sort of maybe presentation, visual presentation, maybe a poster board, maybe a Canva, or it could be simply they are writing down their observations and things and you're sharing that with the class. However you want to help them share what they've learned during their investigation is up to you and them and what you know will work best for you and your students. So that carries out our I do, we do, you do for the descriptive investigation of forces of magnetism. Again, it's that gradual release over time, and you're going to feel like you're talking a lot, which I feel like I'm talking a lot right now, but remember that will shorten as it becomes more of them taking over the ownership and the learning of that process. Okay.
Okay, hello everyone. So now that Jenna went through the model lesson, I'm going to go through some of the components that are in our curriculum to help you be successful with this learning target for magnetism. I'm going to go back to my slideshow. Here we go. Okay. Okay, can you see a slideshow? Okay, so starting off in your curriculum document for the Attraction to Texas, there is a section called the Teacher Clarification section. And we have components of this for each of our learning targets. So in that section, you're going to see definitions, some misconceptions. Sometimes there's some information about vertical alignment. So what the students have learned in previous grades and what they'll build up to going into 5th grade. So for this particular learning target, we gave you some important definitions that go with magnetism and also some clarification around the in contact forces versus at a distance. So we're going to look at Savas here in a few minutes, and you'll see that Savas categorizes magnetism as a non-contact force. But as we saw with our investigation, that magnets can't attract, which they will make contact. And so forces can occur both in contact and at a distance. So that background information is outlined in the teacher clarification. We also gave you a list of possible questions to investigate. So you can utilize those questions with your students as you're going through that gradual release of the I do, we do, you do that Jenna guided us through. And so that section is important for you to read prior to when you start to plan out your resources, just so you're good on the content knowledge and the definitions before you start to carry out and go into Savas and go into the gradual release. Okay, so in your curriculum, this is the resources that you're provided for this learning target. So here at the top, you'll see the descriptive investigation. So that link will take you to the script that Jenna was following for the I do, we do, you do. And there's also teacher support videos for each of those components. So maybe you have a teammate that wasn't able to attend today. That's a great place for them to go to experience those portions of the gradual release and support as far as setup and how to guide your students through that thinking process. And we also have some Savas resources as well. And so we'll go through some of the components of Savas that go with this learning target and also some of the features that you may be familiar with or may not be familiar with. So we asked you to bring a student consumable book with you to this session. So if you can find that and locate it, because we're going to go through some of the resources that are available in Savas for this learning target. And so you can find them within your consumable, so you can see what your students will have access to, and also what you can access in the digital platform as well. Okay, so starting off with our engage. So if you can turn to in your student consumable page 95, and this is in volume 1 of the student consumable workbook. So if you can turn to page 95. And so this is called the Everyday Phenomenon Photo and Activity. So within Savas, their resources are broken into the 5E framework. And so a lot of their resources correspond to each part. So for example, this would be our engage. So this is how you would introduce the learning target, is with this phenomena. And so here they give us a picture, but this is also a really great opportunity to actually demonstrate this phenomena for your students using a real pencil and the ring magnets. And so the title is, how does this object float in air. And so with the engage, it's really meant to be a very quick introduction to get them just thinking and get them interested in the content. And so a great practice for this would be to have your students make observations. So if I can have you do that in the chat, so if you can just put, what is something that you notice from this phenomena? What do you notice? And notice the top ring magnet is slanted. The bottom magnet stays flat. Very good. Okay, so we want to first have our students make observations so they can share these verbally. They can share them with the partner, with their group. This is also a great opportunity to get the students writing. So this would be a really great quick write that they can do in their science notebooks, is to list their observations. And then, so you would first get them to make observations, and then we want them to gather their wonderings, or what are questions that they have about the phenomena. So now, students, what do you wonder, or what are questions that you have about this phenomena? I notice the magnets are repelling away from each other. Good. And as teachers, we know that, right? But just at this point in the lesson, they may or may not know that vocabulary. So yes, Crystal mentioned, why is the top ring floating and not dropping? That's a great question that a student might generate from seeing this image, because that's not what we would expect to happen, right? Very good. So we want to get the students making observations and asking questions. That is really the purpose of our engage. And it's meant to be a quick 5 to 10 minutes using a phenomena. And there is the corresponding page in the consumable textbook that the students could use, or you could just have them record their noticings and wonderings in their science notebook as well. But you can access the everyday phenomenon photos, and in some topics there's videos, and those are available in your Savas digital platform as well. Okay, and then the next part of our 5E, we get into the explore. So this is where we're providing our students with the hands-on experiences with the content. And so Jenna, really the heart of our explore is going to be guiding our students through the descriptive investigations, which is what Jenna showed you in the model lesson. But just an additional supplemental resource for your explore would be your Savas literacy station. And so that is going to be on page 97 and 98 in your student consumable workbook. That's where you're going to see the reading text. And then the activity, or the literacy station activity, is going to be the questions that go with that reading, are on page 101. So you can locate that in your student consumable workbooks. And just something to note, like Kristen mentioned earlier, in Savas, they're also going to cover gravity as well, but we won't complete the gravity part until a later unit. So for now, we're just focused on magnetism. And so you could have your students only read pages 97 and 98 only, since we're just focused on magnetism, and then only answering the questions that are related to magnetism for the Explore. And just remembering that at this point for the Explore, students may or may have not yet mastered the vocabulary. This is just to get them the experience with a lot of the images and an introduction to the vocabulary, because the purpose is that once they have that hands-on experience with the investigations, they can start attaching those vocabulary words to their experience. Okay, so the next part of our 5E is the explain. And so this is where we're really going to have the academic vocabulary and connect that to what we've read about in our read about it and then what we experienced in our gradual release investigations. So for what Savas has the key ideas presentations, which are really like the PowerPoint slides. They have some really good visuals and student engagement pieces like guiding questions and matching and things like that. And also the short key ideas videos. Something to note in Savas that when you go into the platform, you can actually download the key ideas presentations as a PowerPoint. And once you do that in the PowerPoint notes, and I'll show you on my screen. There it is. There we go. So you can see here, I downloaded the key ideas presentation from Savas. And when you click notes here at the bottom, there's some really good teacher notes and discussion points of key ideas that you can go over with your students and having them help them reinforce that vocabulary. So again, this is when you download the key ideas presentation as a PowerPoint. And if you're needing maybe some additional support with some of the components of Savas, especially in the digital platform, our team created some teacher support videos around accessing material in Savas. So at some point, if Kristen, you can put in the chat the videos that they can access, because we have videos for each component, the read about it, the key ideas presentation and videos, and how to access those and utilize them in your classroom. Okay. Go here. Okay, so then the instructional resources for Elaborate, Savas also has the STEAM Station card and activity. And so the activities, like we mentioned for the everyday phenomena, the key ideas, anytime it says activity within Savas, those are going to be pages within the consumable workbook. So your students will have that already in their workbooks. Okay, and then the last part of our 5E is the evaluate, which is the assessment portion. Now, this is not always a summative assessment. It can be quick. It can be a journal entry. It can be an exit ticket. In this particular learning target, we included the Savas quiz. So within that quiz, there are questions about gravity as well. So we just want to remember we're focusing just on the magnetism. So the Savas quizzes, you can assign those directly to your students in the Savas platform, or you can also print them as well. And they're both versions, the digital and the printable, are editable. So you can take out the questions that you don't want. Students can also listen to them if they have those accommodations in their IEPs or learning plans. Okay, and then lastly, supporting the students in your class with visuals. So our Savas comes with the vocabulary cards. So these would be the cards that go along with magnetism, also providing your students sentence stems and frames. So even if you're, for example, utilizing the read about it in their student consumable, maybe you assign them a paragraph in their notebook and you provide them a sentence stem to answer the questions in the literacy station activity. That would be a great way that you can really support the diverse students in your class and really all your students. Okay, and now I'll hand it over to Kristen for questions.
All right, give them to me, guys. What questions do you have?
I know somebody had it asked.
Any questions?
I saw one earlier, Kristen, about sharing Jenna's notebook. And so we can do that right after we put up the feedback form, or even, let me see if I have it.
I wonder if we can link
I can do it now. Here.
We could even take a picture and directly link it into the script.
We can do
Because we've
that.
done that with some of our others, so maybe we could do that. So then it'll be right there in the script in your curriculum, and it'll be for everyone. That works?
Yes.
Good question. Sorry, I hope I didn't miss any others. Okay, well, if there are no more questions, I'm going to stop recording. If you are live, stay with me because after this, we are going to give you a feedback form to fill out to get attendance. And if you're watching this asynchronously, you can now go take your quiz so you can get your teacher choice credit. So I'm going to go ahead and stop recording.